Alright, let's go. Number 10. The entropy that lives on the surface. In 1972, Jacob Bekenstein was a graduate student at Princeton working under John Wheeler on a problem that sounds almost trivial. Wheeler had made an offhand remark over tea: if you drop a cup of hot liquid into a black hole, you have just erased its entropy from the universe, and the second law of thermodynamics is violated. Bekenstein set out to patch the bookkeeping. The rule he was trying to protect is the most reliable statement in physics. Entropy never decreases, and in every ordinary system, entropy scales with volume. Double the size of a box of gas, and you double the number of microscopic arrangements available to it. Entropy is a property of the inside of things. Bekenstein found that a black hole's entropy scales with the area of its horizon, not the volume, the surface. Bekenstein published this in 1973 in Physical Review D, Volume 7, page 2333. Hawking, who initially thought Bekenstein was wrong, fixed the coefficient 2 years later. The entropy equals 1/4 of the horizon area measured in Planck units. For a black hole the mass of the Sun, the number comes out near 10 to the power of 77 in units of Boltzmann's constant. The Sun itself, burning right now, carries roughly 10 to the power of 58. Collapsing the Sun into a black hole would multiply its entropy by 19 orders of magnitude. Physicists tried to make this ordinary. First proposal: the formula is a formal analogy, mathematics that resembles thermodynamics without being thermodynamics. That collapsed when Hawking derived a real temperature. Second, the entropy belongs to the infalling matter, stored somewhere inside. That failed because the entropy depends only on mass, charge, and spin. A black hole made of encyclopedias and a black hole made of hydrogen have identical entropy. Third, statistical mechanics will eventually find the microstates. Strominger and Vafa found them in 1996 in Physics Letters B, but only for a highly idealized supersymmetric class of black holes that do not exist in our sky. Fourth, the holographic principle, proposed by Gerard Hooft in 1993 and developed by Leonard Susskind in 1995, the idea that all the information in a volume of space is written on its boundary. This explains the area law by proposing that the interior of the universe is a projection, which means the information describing your body right now may not be located where your body is. It may be encoded on a distant surface, and you are the shadow it casts. Why does nature store the contents of a room on its walls? Nature's second answer to that question was worse, because it turned the surface into a fire. Number 9. The radiation nobody has ever seen. Hawking's original goal was to prove Bekenstein wrong. He found the entropy claim absurd, and in 1973 he sat down with the machinery of quantum field theory and curved spacetime to demonstrate that a black hole cannot have a temperature. He was doing a demolition job on a student's paper. The premise was not controversial. The event horizon is a one-way membrane. Classical general relativity is unambiguous. Nothing crosses outward, not light. Not matter, not information. A black hole can only grow. The calculation returned radiation. A perfect thermal spectrum, leaking outward, cooling the whole until nothing remained. Hawking published it in 1975 in Communications in Mathematical Physics, Volume 43, page 199. The temperature of a black hole one solar mass in size is 6.2 times 10 to the minus 8 Kelvin. The cosmic microwave background sits at 2.725 Kelvin. Every stellar black hole in the universe is currently absorbing far more than it emits. A solar mass hole would take roughly 2 times 10 to the power of 67 years to evaporate. The universe is 1.4 times 10 to the power of 10 years old. So the prediction has never been tested. Searches for exploding primordial black holes by Fermi-Lat, by Hess, have returned nothing. Analog experiments in Bose-Einstein condensates, run by Jeff Steinhauer at the Technion and published in Nature Physics in 2016, produce something that behaves like Hawking radiation and sound waves, but critics point out that sonic horizons do not test the gravitational derivation. Only its mathematical skeleton. And the derivation has an internal wound, trace the outgoing modes backward in time and their wavelengths shrink below the Planck length, into a regime where no known physics applies. This is the Transplanckian problem. William Unruh argued the result survives regardless of what happens down there. His argument is a plausibility argument. It is not a proof. The most consequential claim ever made about black holes, that they die, rests entirely on mathematics that has never once been confirmed by observation. What if the thing we have been calculating the death of does not die? Some black holes are not merely unexplained. They are spinning faster than they should be able to. Number 8. The spin that approaches the wall. Jeffrey McClintock and his collaborators at the Harvard-Smithsonian Center for Astrophysics were doing routine X-ray astronomy. The method is mundane. Measure the thermal continuum from the accretion disk, work out the radius of its innermost stable orbit, and back out the spin. It is a technique for filling in catalog entries. The Kerr solution sets a hard ceiling. Spin parameter a star cannot exceed 1 without the horizon disappearing entirely. Kip Thorne showed in 1974 in the Astrophysical Journal Volume 191, page 507, that radiation captured by the disk cap's realistic astrophysical spin up at 0.998. Nothing should sit at the wall. GR's 1915 plus 105 came back above 0.98. McClintock and colleagues published this in 2006 in the Astrophysical Journal, Volume 652, page 588. Go and collaborators measured Cygnus X1 in 2011 in the Astrophysical Journal, Volume 742, Article 85, at greater than 0.95, later refined upward past 0.98. Two independent objects, sitting within 2% of a theoretical boundary. The disk model was the first suspect. Astronomers cross-checked with the iron line method, which uses relativistic distortion of a spectral line rather than disk temperature, and the two techniques agreed. Inclination error was the second suspect, ruled out by independent orbital measurements. The third explanation was accretion spin up. The hole ate its way to that rotation. Cygnus X1 has not swallowed enough mass in its lifetime to do it. So it was born spinning that fast, and stellar collapse models do not produce cores with that much angular momentum without violating what we know about magnetic braking inside massive stars. If any real black hole ever crossed a star equal to 1, the horizon would vanish and the singularity would become visible. Not hidden. Exposed to telescopes and to eyes. Roger Penrose called the prohibition against that cosmic censorship. He was never able to prove it. The next object did not break a limit. It appeared in a place theory said was empty. Number 7. The object from the forbidden gap. On May 21, 2019, the LIGO and Virgo detectors registered a signal lasting about 1/10 of a second. 4 cycles. The analysis pipeline was running as it always does, and the event was short enough that some team members initially wondered whether it was a glitch in the instrument. Stellar theory has a hole in it, and the hole is well understood. Stars with helium cores between roughly 65 and 120 solar masses undergo pair instability. Gamma rays inside the core convert into electron-positron pairs. Pressure support collapses, and the star detonates completely. It leaves nothing behind. There should be no black holes in that mass range. This is the pair instability mass gap. The heavier object in the merger weighed 85 solar masses. The collaboration published it in 2020 in Physical Review Letters, Volume 125, Article 101102. Component masses of about 85 and 66 solar masses, producing a remnant near 142 solar masses, with roughly 8 solar masses of material converted to gravitational waves in a fraction of a second. The source sits about 5 gigaparsecs away, at a redshift near 0.8. Explanations arrived quickly and each one strained. Hierarchical merger, the 85 was itself built from 2 earlier black holes. Requires an environment with escape velocity high enough to retain the remnant against recoil kicks, which limits you to globular cluster cores or the disks of active galactic nuclei, and the predicted rate falls short. Primordial black holes from the early universe would explain it, but no independent evidence for them exists. Moving the pair instability boundary is possible if the carbon-12 alpha-gamma oxygen-16 reaction rate is different from what nuclear experiments suggest, but shifting it far enough breaks the abundance of oxygen in the universe. In a reanalysis by Alexander Nitz and Colin Capano in 2021, in the Astrophysical Journal Letters Volume 907, Article L9, argued the masses might be 170 and 66 solar masses instead, which does not solve the problem, it relocates it. Every atom heavier than iron in your bloodstream was forged by stellar death. We have a signal from a star that died in a way our theory says is impossible. How many of them are out there? In a mass range we have been telling ourselves is empty. The following anomaly is more contested, and if it holds, it removes the horizon altogether. Number 6. The echoes after the ringdown. Nyayesh Afshorti's group at the University of Waterloo and the Perimeter Institute, with students Jahed Abedi and Hannah Dakar, were examining ringdown data from the first LIGO detections. The ringdown is the settling phase, the final tremor as a newly merged black hole relaxes into its stable shape. It is the least dramatic part of the signal. General relativity gives an exact prediction for what follows. The ringdown decays smoothly, following a known set of quasi-normal frequencies. And then, there is nothing. The horizon absorbs everything falling back inward. Silence is the signature of a true event horizon. They reported faint pulses repeating after the signal should have ended. Abedi, Dakar, and Afshorti published in 2017 in Physical Review D, Volume 96, Article 08204. The echoes were spaced at intervals near 0.1 seconds, and they quoted a significance of 2. 9 sigma, a false alarm probability of roughly 1 in 270. The refutations were immediate and partial. Gregory Ashton and colleagues at the Albert Einstein Institute challenged the noise model directly. Julian Westerweck and collaborators reran the analysis in 2018 in Physical Review D, Volume 97, Article 124037, with different background estimation and found the significance fell to 1. 6 sigma or below. A Bayesian reanalysis by Nielsen and colleagues in 2019 found no support. But nobody has produced a clean refutation either, because the echo templates have free parameters, and the look elsewhere effect cuts in both directions. The claim has been neither confirmed nor killed. It has simply been left standing in the road. If the echoes are real, the object has a reflecting surface a Planck length outside where the horizon should be, which means nothing in the sky has ever actually been a black hole. We would have named the most studied objects in modern astrophysics after a feature they do not possess. Whatever these objects are, they process information faster than anything else in nature. Number 5. The Scrambling Limit. In 2007, Patrick Hayden and John Preskill at Caltech were working a quantum information puzzle with no obvious astrophysical stakes. Drop a single qubit into a black hole that is already halfway evaporated. How long before you could reconstruct that qubit by collecting the outgoing radiation? It was a coding theory question. Ordinary systems mix slowly. Stir cream into coffee and the mixing time scales with the size of the cup. Diffusion is a local process, and information spreads at the speed of the local dynamics. Bigger systems take longer. Black holes scramble in a time proportional to the logarithm of their entropy, the fastest that quantum mechanics permits anything to scramble. Hayden and Preskill published in the Journal of High Energy Physics in 2007. Yasuhiro Sekino and Leonard Susskind formalized it in 2008 in the same journal, giving the scrambling time as the horizon light crossing time multiplied by the logarithm of the entropy. For a solar mass black hole, that is about 10 to the minus 5 seconds multiplied by 177. 2 milliseconds. In 2016, Juan Maldacena, Stephen Schenker, and Douglas Stanford proved a universal bound on chaos in the Journal of High Energy Physics. The Lyapunov exponent of any quantum system cannot exceed 2 pi times the temperature divided by h bar. Black holes do not approach that bound. They saturate it exactly. Physicists looked for an escape. Coincidence was the first. Perhaps saturation is an accident of the specific model. It holds across every model tested. Second, an artifact of the semi-classical approximation. The bound was derived from analyticity and unitarity alone, with no gravity in the argument. Third, other systems saturate it too, so it is not special. The Sokhtev-Yekitev model does saturate it, and that model turns out to be dual to a black hole. The exception was the same object wearing different notation. Whatever pattern of particles constitutes your memories, your face, your history, a black hole would erase its structure faster than any other process the laws of physics allow. Why does the most destructive object in nature operate precisely at the theoretical maximum of destruction? The deeper problem is that at the center, our equations stop producing answers at all. Number 4. The singularity is a failure notice. In 1964, walking across a street in London, Roger Penrose was thinking about a loophole. Everyone assumed the infinite density at the heart of collapse was an artifact of assuming perfect spherical symmetry. Real stars are lumpy. Lumpy infalling matter should miss the center, swirl past, and avoid the point of infinite density entirely. That expectation was reasonable and universally held. Asymmetry saves you. Nothing in nature is a perfect sphere, so nothing in nature should produce a true singularity. Penrose proved that once a trapped surface forms, the singularity is unavoidable. Symmetry is irrelevant. He published it in 1965 in Physical Review Letters, Volume 14, page 57. 3 pages. He and Hawking generalized it in 1970 in Proceedings of the Royal Society A, Volume 314, page 529. Penrose received the Nobel Prize for it in 2020, 55 years later. The escape routes have all narrowed. Quantum gravity will smooth the singularity, but no complete theory of quantum gravity exists. So this is a promissory note. Loop quantum gravity predicts a bounce at Planck density, but the bounce models rely on symmetry assumptions that reintroduce precisely the problem Penrose eliminated. The singularity is a coordinate artifact, like the horizon. No, because curvature and variance diverge, and invariants do not care about coordinates. Exotic matter violating the energy conditions could prevent it, but no macroscopic violation has ever been observed. Fuzzballs replace the interior entirely, constructed only for special supersymmetric solutions. General relativity is the most precisely tested theory in the history of science, verified to 11 decimal places by binary pulsar timing. And it predicts, from its own equations, the existence of regions where it ceases to be true. What does it mean for a theory to be correct about the location of its own failure? There is one proposal that saves the equations by giving up something more expensive. Number 3. Complementarity and the Two True Stories. By the early 1990s, Leonard Susskind at Stanford was trying to rescue information from Hawking's paradox without breaking relativity. The proposal was intended as a conservative fix. Keep quantum mechanics, keep general relativity, and accept a small adjustment in how we describe observers. The adjustment is not small. In all of physics before this, observers can disagree about durations, lengths, and simultaneity, but never about whether an event occurred. Relativity's disagreements are reconcilable, apply a transformation, and the accounts merge. Complementarity says the infalling astronaut crosses the horizon unharmed, while the distant observer watches them burn and sees their information return in the radiation. Both descriptions are correct. Neither is an illusion. Susskind, Laris Thorlacius, and John Uglum published this in 1993 in Physical Review D, Volume 48, page 3743. The consistency argument is precise. For anyone to detect the duplication, the outside observer would have to collect the radiation and then dive in to compare notes, and the time required exceeds the time available before the interior signal reaches the singularity. The contradiction is unobservable by construction. Objections came from every direction. It is just observer dependence. No, because no transformation converts one account into the other. It is anti-realism dressed as physics, abandoning the idea that there is a fact of the matter, a charge Gerard Hooft and others pressed hard, and which has never been answered. only absorbed. And in 2013, a group at Santa Barbara demonstrated that complementarity is internally inconsistent. Maldacena and Susskind proposed ER equals EPR in 2013 in Fortschritte der Physik to repair it, identifying entanglement with wormhole geometry. It remains unproven. Whether you died is not, under this proposal, a fact about the universe. It is a fact about where the observer is standing. Which observer is you? The paper that broke complementarity was written by people trying to confirm it. Number 2. The Firewall. In 2012, Joseph Polchinski assigned what he considered a routine exercise to Ahmed Almheri, Donald Marolf, and James Sully at UC Santa Barbara. Check whether black hole complementarity is self-consistent. Polchinski expected a short paper confirming that it was. He had been one of its supporters. The assumption under test is the oldest one in the field. The equivalence principle says free fall is indistinguishable from floating in empty space. Crossing the horizon of a large black hole should feel like nothing at all. Einstein called the insight behind it the happiest thought of his life. 3 propositions cannot all be true: that evaporation is unitary, that physics outside the horizon is ordinary, and that infall is uneventful. Almheri, Marolf, Polchinski, and Sully published in 2013 in the Journal of High Energy Physics, Volume 2013, Article 62. The mechanism is monogamy of entanglement. 4. Unitarity. Each outgoing Hawking quantum must be maximally entangled with the radiation already emitted. For a smooth horizon, it must be maximally entangled with its partner behind the horizon. Maximal entanglement cannot be shared. Severing the interior bond costs energy, and the horizon becomes a shell of high-energy quanta. The crisis begins at the page time. Defined by Don Page in 1993 in Physical Review Letters, Volume 71, page 3743. The moment when half the entropy has radiated away. Every repair has cost something. ER equals EPR is unproven. State dependence, developed by Kyriakos Papadodimas and Suvrat Raju, makes interior operators depend on the quantum state, which violates the linearity of quantum mechanics. Fuzzballs exist only in supersymmetric constructions. The island formula and replica wormholes, developed by Geoffrey Pennington and by Almheri, Engelhardt, Marolf, and Maxfield beginning in 2019, successfully reproduce the Page curve from the gravitational path integral, a genuine advance. But the interpretation of those saddle points is disputed. And the formalism still does not say what the infalling observer feels. Halfway through its lifetime, a black hole may quietly replace an open doorway with a wall of radiation at Planck scale energy. From outside, nothing would look different. You could not tell, from any observation available to you, whether the object you are looking at has already crossed that line. All of it descends from one calculation Hawking published, and then spent 30 years trying to escape. Number 1. The destruction of the past. Having derived the radiation in 1974, Hawking followed the logic to its endpoint. He was not hunting for a paradox. He was asking a straightforward question about the final state: the hole shrinks, the radiation streams out, the mass reaches zero. What is left? Quantum mechanics gives one answer, and gives it without exception. Evolution is unitary. A pure state remains a pure state. Information about the past is scrambled beyond practical recovery but never destroyed. Burn a book and the correlations survive in the smoke, in principle recoverable by a sufficiently patient observer. This is not an assumption. It is the structure of the theory. Hawking radiation is exactly thermal. It carries no imprint of what fell in. When the last of the whole evaporates, the information is not scrambled. It is gone. Hawking published this in 1976 in Physical Review D, Volume 14, page 2460, under the title Breakdown of Predictability in Gravitational Collapse. In 1997, he and Kip Thorne bet John Preskill that information is destroyed. Hawking conceded in 2004 at the Dublin Relativity Conference and handed Preskill a baseball encyclopedia. Thorne has never conceded. The proposed solutions have each failed on a technicality that matters. Information emerges in late radiation. This requires correlations that Hawking's own calculation says are absent. Information survives in a Planck mass remnant. A remnant with enough internal states to encode a galaxy's worth of information would be produced in unbounded quantities by ordinary particle collisions. Information escapes into a baby universe, indistinguishable from inside our universe, from destruction. The AD-S/CFT correspondence, established by Maldacena in 1997, proves unitarity holds in the boundary description, but it does not identify the mechanism, and our universe is not anti-de Sitter space. Soft hair, proposed by Hawking, Malcolm Perry, and Andrew Strominger in 2016 in Physical Review Letters Volume 116, Article 231301, identifies conserved charges on the horizon, but nobody has shown they carry enough capacity. Every physical process you have ever undergone assumed a recoverable past. The universe, on this account, contains a mechanism for removing history, not hiding it, not encrypting it, removing it.